Now that you're working on your first homework for the second semester on heat and thermodynamics, I want to fulfill my promise of using these videos more. So here is me working out numbers 1 through 5 of this homework. In number 1, you're given two temperatures, but you're only really concerned about this one, 14 degrees Celsius. And you want to convert this one to both kelvins and degrees Fahrenheit. So to convert to kelvins, kelvins is equal to Celsius plus 273. So all I have to do is say 14 plus 273, and that gives me 287 Kelvin. That was easy. The harder one, which really isn't that much harder, is converting to Fahrenheit. Now Fahrenheit is equal to 9/5 times C plus 32. So all I have to do is substitute 14 for C, and when I do that math, I get this temperature in Fahrenheit is 57.2 degrees Fahrenheit. Now in number 2, I start off with 400 degrees Fahrenheit, and I want to get it in both Celsius and Kelvin. So the best way to do this is to solve for Celsius first. So the formula for that is C is equal to 5/9 parentheses F minus 32. And so C is equal to 5/9. I substitute in 400, subtract 32 from that. When I solve for C, I get the degrees in Celsius is 204.4 degrees Celsius. But now once I have it in Celsius, converting to Kelvin becomes easy because all I have to do is say whatever it is in Celsius plus 273 is my temperature in Kelvin. And so if I add 273 to that, I just get 477.4 Kelvin. Number 3 again starts with something in Fahrenheit, but now I only want to get it in Celsius. And so again, the formula for that conversion is 5/9 times F minus 32. And so I substitute in my degrees in Fahrenheit, and I would get the answer is 460 degrees Celsius. Number 4 has to do with temperature change, so it involves a little more thought than just converting blindly. So it tells me my temperature difference is 49 degrees Fahrenheit, but my final temperature is 7 degrees Celsius. And I want to know what were the initial and final temperatures in Fahrenheit, and then what was the temperature in degrees Celsius before the temperature increase, or basically what was the initial temperature in Celsius. The first thing I can do is take this final temperature here, which is in Celsius, and convert it to Fahrenheit. So I do that using the formula. And if I plug in 7 for my degrees Celsius, I get that final temperature in Fahrenheit is 44.6 degrees Fahrenheit. And so delta T is equal to my final temperature minus my initial temperature. So if I have my delta T and I have my final temperature, I can easily solve for my initial temperature. And if I do that, I get my initial temperature is negative 4.4 degrees Fahrenheit. So now I have both my initial and final temperatures in Fahrenheit, I already have the final temperature in Celsius. Now I need to find what's the initial temperature in Celsius. So I take this number and I have my conversion to Celsius, and I plug that in. So this is negative 4.4 degrees minus 32, and I get the temperature in Celsius is negative 20.2 degrees Celsius. So my initial temperature in Celsius is 20.2 degrees. Again, in number 5, I have a problem about changing temperatures, and I'm again given the final temperature, this time in Celsius, at negative 49 degrees Celsius. It also gives me my change in temperature over the 24-hour period was 56 degrees Celsius. So what I can do is I can use that and say my change in temperature is equal to final minus initial. So 56 is equal to negative 49 minus my initial. So my initial is 7 degrees Celsius, because this 56 was actually a negative. It decreased, it dropped that much. So now that I have both initial and final, I can convert those both to Kelvin. And so if I convert my initial to Kelvin, I just add 273 to 7, which gives me 280 Kelvin. And then my final is negative 49 plus 273, or 224 Kelvin. And that's it for this part of the homework. Look out for more videos on the next problems.